Or we say, just look at the experimental phenomenon. I am now accessing 20.1 from 10.1 here on PC1. So now can I communicate? Let's take a look. Ping 192.168.20.1. It works now. Cross-network segment. Walked 3 floors. And we also divide the VLAN. We are taking the one-armed route. Let's make a summary. We first send out a data here. Here. Belong to VLAN 10 and tag 10. Released 10 and 20 here. And the default native VLAN of the interface is 1. So I keep this 10 and send it over. Send here. Hand it over to the current subinterface 00.10. It is located exclusively at .1Q10. It is designed to handle 10 tags. Then a subinterface like this. When receiving data, this 10 will be stripped off. So in this 10 it is stripped off. Then the router officially starts processing. After the router is processed, query the local routing table for forwarding. In the routing table you will find the next hop will be VLAN 20. You may not understand this. We'll talk about that later. We know it's coming here later. Before sending down. When sending, it needs to go through the local .20 subinterface. Then put VLAN tag 20 in it. Then send out. Our trunk needs to be released. After release, it came to the access interface with 20. After stripping off the 20, pass to PC2. So let's now look at the routing table. Show IP route. Now we will find out. Now we actually have to go from the subinterface. Because what we are configuring now is the subinterface. Because we are configuring the address for the subinterface. And we are now using the normal subinterface. So it goes through the subinterface. When its next hop matches the upper subinterface, then it will mark the corresponding tag on the subinterface. For example, I query to go to network segment 20. My outgoing interface is now .20. Then I'll tag 20. A data comes in. If the data is processed by the subinterface .10, I'll take this 10 off. So for subinterfaces, an interface to receive data. Strip off the tag. Send data. Tag. Who does this subinterface belong to? We'll strip whoever and beat whoever. And to make an emphasis to everyone. Inside Cisco, there is a capability called ARP broadcast in the subinterface. We just missed a link. PC this sends a data. Here. It requests the MAC of the gateway. Subinterface. The subinterface wants to send an ARP request to the 20.0 network segment. PC1 come here now. Request gateway MAC. The gateway is going to request the MAC of PC2. The gateway is now going to forward data. But for subinterfaces, Cisco subinterfaces can send out ARP broadcasts. Okay. This is also an experiment that I will leave you with today. Finally, let's talk about Layer 3 VLAN. The following configuration does not need to be changed. I just stop this device. Then turn it back on. For this device, just wait and reconfigure access. You can imagine that there is a virtual router in the switch. The router has its own interface. This interface can be configured with IP. I'm in the switch. Configure an IP address for VLAN 10 and VLAN 20 below. As the gateway of the PC below. Let me tell you about the process. The ARP we mentioned earlier. And the MAC address table we talked about today. This requires you to have a very godly understanding. Let's talk about it. How did it work? PC1 now wants to access PC2 across network segments. First it requests the MAC of its own gateway. It wants to send an ARP broadcast request. Send data to the switch. Tag 10 here. Then the switch is actually a fake router. Actually, the switch itself can handle. It's just that routers may be better understood by everyone. The switch itself will disassemble the data packet. After dismantling, you will see 3 layers. After seeing the 3rd floor, it is equivalent to entering the switch after typing the tag here. It will unpack itself. It will see 3 layers. The IP address requested by PC1. It is the IP address configured in this VLAN 10. Then the switch will reply to PC1. The switch is called backplane MAC. That is, there are no MACs under the interfaces of many switches. Only one backplane MAC. It's just a MAC address written on the back panel. For the entire switch, reply to the PC with its MAC address. After the reply, the ARP is over. PC gets its MAC. Start data encapsulation. When it goes to request, the switch starts sending data directly to PC2. But the purpose of encapsulation MAC is, the backplane MAC of the switch just replied. That is, VLAN 10 MAC. Just send it. Switch to see the destination MAC is it. It depends on 3 layers. The 3rd layer you want to go is PC2. It checks the routing table. This is its direct connection. Wait a minute, we look at the routing table. It will display VLAN if 20. This is the next hop. For us now, the next hop to PC2 is VLAN if 20. This is a logical port. But everyone must pay attention. A logical port is, after all, a logical. The real data must be sent from the real physical interface. So which interface is it sent from? We will now go and send the ARP request. Request MAC for PC2. So which physical interface is this broadcast packet sent from? How to judge? At this time, the broadcast message. It will be sent from all interfaces that allow VLAN 20. For example, here is the switch below. There is an access interface. Belongs to VLAN 20. This interface also sends. There is a trunk interface. It passes VLAN 20. This interface also sends. All interfaces that allow VLAN 20 to pass through will be sent. Then send an ARP broadcast request. This is called VLAN if 20. In short, you will understand. Even if there are other interfaces are sent. But this data will definitely be sent to PC2. Because it belongs to VLAN 20. Then when PC2 receives this message, it's going to reply. It will reply its own MAC to this switch. Then the switch learns. Now the 01 interface corresponds to the MAC of PC2. It has an ARP table on itself. The record is IP and MAC. It now has a MAC address table on it. Record MAC and interface. So when the data is actually forwarded again, it knows to send out from this interface. What I said may be a little complicated. You must figure out its overall communication principle. That is to say, next hop is VLAN if 20. This is a virtual interface. What physical oral hair? All interfaces that allow VLAN 20 to pass. It's just that this broadcast packet is sent out. Only PC2 will reply. Because the request is its MAC. In ARP, target IP is PC2. Only PC2 replies. Once it's back, data flows through the interface of the switch. Will appear in its MAC address table. So the interface matches the MAC. Simultaneously, PC gets ARP reply. IP and MAC are also matched. Then the IP and MAC interfaces are all matched. Future access PC2. The switch knows that it is sent from the 01 interface. So, although the next hop you see in the routing table is a virtual interface, but actually for the switch, it can find the real physical outgoing interface. If you don't understand, you can take a look after class. It's normal to not understand the first time, but I've made it as clear as possible.